All right, so in this section 2 of limits, we're going to talk about some other techniques for evaluating limits. So first off, this is for use when your direct substitution doesn't work. If you can just plug the number in that you are approaching, then by all means do that. If you can't, because that gives you the indeterminate form where you have a 0 in the denominator, then you can try other techniques. So first off, we're going to talk about the dividing out technique. So I am approaching -3, but if I were to substitute in -3, I would get a 0 in my denominator, and that's a problem. So if I was able to get rid of this problem area down here, then that would be ideal. Then I could plug in at some point. So I look at the top, and I see that I could factor the top part. So I would get x plus, x minus, and the number that multiplies to make 6 and subtracts to make 1 would be 3 and 2. And I want the middle to be positive, so 3 will go with the plus. All right, the bottom cannot be factored, but I can see that I have a common factor here of x plus 3. So I'm going to cancel that out, and I'm left with x minus 2. So now that that's simplified and I no longer have that problem area in the denominator, I can go ahead, plug in the -3. So the limit as x approaches -3 of this equation is -5. All right, on number 2, I have the limit as x approaches 6. Well, if I plug a 6 in this denominator, 6 squared is 36, minus 36 is 0. So I'm going to go ahead and factor that denominator. I have the difference of 2 squares, so that will lend me x plus 6 and x minus 6. All right, so the problem area in this is that this 6 minus 6 gives me a 0, but I can end up canceling out that problem factor. When I do that, anything divided by itself is 1, so this gives me 1 over x plus 6. And now I can plug the 6 in for that x, and I have 1 over 6 plus 6, which gives me 1 over 12. Now, if you were trying to find that graphically, it would be really hard to tell that 1/12 was the limit. So the dividing out technique worked really well for this one. All right, so on number 3, we are approaching 1, but if you plug a 1 in down here, you're going to get a 0 in the denominator. So I'm going to have to factor that bottom, and I have 4 terms, which means I have to factor by grouping. So I'm going to group together the first 2 terms plus, and then group together the back 2 terms. All right, my numerator is just kind of chilling. So I look at this first set, and I can factor out an x squared, which leaves me with x minus 1. There's nothing to factor from this, so I'm just going to go ahead and write a 1 in front of that so I don't forget that I have a 1 there. And then to finish out the factoring of that denominator, you're going to factor out what they have in common, or their common factor, which is x minus 1. So that goes in the front. So if I divide this by x minus 1, I am left with x squared. And over here, I am left with plus 1. Now I can cancel the x minus 1. All right, and that leaves me with 1 over x squared plus 1. And at this point, I can plug in the 6, so 1 over 6 squared plus 1, which gives me 1 over, oh, it's not a 6, it's a 1. I'm approaching 1, not 6. So plug in the 1 squared plus 1, which gives me 2. So my limit is 1/2. So sometimes when you can't use direct substitution and there's no way to divide it out by factoring, then you will rationalize. That's when you have a root in your function. So just a side note, just to remind you that the conjugate of the square root of x plus 4 would be the square root of x minus 4. So if I'm looking at number 4 here, I see that trying to plug in a 0 right here is going to give me a 0 in my denominator. So what I'm going to do is I'm going to multiply by the conjugate of the top, which would be x plus 1, or the square root of x plus 1 plus 1. So just changing that sign right there. And then I'm going to put the same thing on the bottom. You have to do it to the top and to the bottom. And then I'm just going to multiply both of these terms by both of these terms, and then same thing on the bottom. So I have the square root of x plus 1 times the square root of x plus 1, which gives me x plus 1. Then I have a positive square root of x plus 1 times 1, which would give me a positive square root of x plus 1. Then I have a negative 1 times the square root of x plus 1, which would give me a negative square root of x plus 1. And then a negative 1 times a positive 1, which is negative 1. These two terms in the middle, when you do the outside and the insides, those should always cancel. So if you don't want to do the outside and the inside, you can just do the fronts and do the backs, and that would be sufficient. So on the bottom, I'm actually going to leave the bottom separate until I come to the conclusion that I need to put that back together. All right, so on the top, these two are going to cancel, and then the positive 1 and the negative 1 also cancel. So I am left with x over x times the square root of x plus 1 plus 1. And I see that I have x and a factor of x here, so I can cancel those, which is going to leave me with 1 over the square root of x plus 1 plus 1. So that eliminated the issue right there. Now I can go ahead and plug in the 0. So I'm approaching 0, so I'm going to substitute in 0. So that gives me 1 over the square root of 1, which is 1 plus 1, so 1 half. All right, same thing here. I'm going to go ahead and multiply by the conjugate, which is the square root of 5 plus x plus the square root of 5. And I'm going to do that on top and bottom. By the way, sometimes the root is in the bottom. You still do the same thing by multiplying by the conjugate on the top and the bottom as well. So I multiply, and remember, when I do the outsides and I do the insides, those should cancel out. So I'm only going to multiply the fronts and the backs. So the square root of 5 plus x times the square root of 5 plus x is 5 plus x. And the negative square root of 5 times the positive square root of 5 is negative 5. And I'm going to go ahead and cancel those two out. So all I have left on top is x. On the bottom, I have x times the square root of 5 plus x plus the square root of 5. And I see that my factor of x will cancel, leaving me with 1 over the square root of 5 plus x plus the square root of 5. So now that that problem area has been removed, I can plug in the 0. So I get 1 over the square root of 5 plus 0 plus the square root of 5. Now this one is not going to come out to be a nice, neat number, because the square root of 5 plus 0 would just be the square root of 5. And if I take the square root of 5 plus the square root of 5, that gives me 2 square roots of 5. But we don't like to leave these roots in the denominator, so you can either have your smaller calculator fix that for you, or you can rationalize by hand by multiplying by the square root of 5. So that gives me the square root of 5 over, we've got 2 times 1 is 2, and square root of 5 times square root of 5 is 5. So 2 times 5 is 10. Now, every now and then, none of these techniques work. You can't substitute. You can't divide out. You can't rationalize. Seems like there's nothing for you to do. All right? That's when you're going to have to just do it numerically with a table. So I'm going to make a table of values here, just kind of like we did in section 1 of limits. So I'm approaching 0. And this time I think I'm just going to choose negative 0.001, negative 0.002, and negative 0.003. And same thing on the right-hand side, 0.001, 0.002, 0.003. In some circumstances, that doesn't seem to be close enough, and you might want to do like the 0.0001, 0.001, 0.01. That would be sufficient as well. And instead of plugging these in just by hand here, I'm going to go ahead and use my calculator to help me with that. So let's plug in the 1 plus x raised to the 1 over x power. You want to make sure that your table is set up to ask for the independent variable. All right, my table does have some values in it. I'm going to replace those. So it's really hard to tell what I'm approaching as I approach 0 right here. If I'm going to move this down some, I can't really tell, but I can see that as I approach 0, it's going to be a decimal. It's definitely not going to be like on 3. Because where they meet up right here from either side should be about right in here. So I'm going to go ahead and replace my table with the values that I have chosen. So I have negative 0.003, negative 0.002, negative 0.001. I'm going to go ahead and plug in 0, but you're going to get an error. And then I have the 0.001, 0.002, and 0.003. All right, and you can fill that table in on your paper. I'm not going to for this video. But as you can see right here, this is what I'm approaching. And from either side, you can tell it's not coming to anything that like a half or a third or a fourth or even a whole number, so or an integer. It's just going to be somewhere in between these two, and it should be halfway because these are equally distant on either side of 0. So since you can't tell what this is, you're going to take both of these numbers and you're going to average them. So I'm going to take the 2.7196, I'm going to add that to the 2.7169, and I'm going to divide by 2. All right, and again, you could fill in your table here. So this is going to be 2.7196 plus, on the other side, the 2.7169. I'm going to divide that by 2 and average them so I can see what is directly in the middle. And you're going to get a limit of approximately 2.71826. All right, so on number 7, we're going to do the same thing. I see that I can't directly plug in. There's no root for me to rationalize. I can't factor and divide this out. All right, so I'm going to make a table of values, and I am going to use my graphic calculator to help me fill in that table. So this time I'm going to use the negative 0.001, negative 0.01, and negative 0.1, and same thing on the other side of 0. And those are the values that I'm going to plug into my calculator. All right, so I've got E. Now remember to get an E, it's second and the natural log button over here next to the 4. That's if you want an exponent. If you don't, you can use the division one as well. There's 2 E's. All right, so I have e to the 2x minus 1 over x. I go to my graph, and if you're looking at this, it really looks like it's going to be 2. So from the left-hand side, as my x's get closer to 0, I'm getting closer to this location. And same thing here, closer to this location. Looks like they're going to meet up at 2. So I'm going to go ahead, and if you look at this, I actually don't even need to pick the values that I did. These values would work as well. You could replace them, but you're going to get something very similar. If you look at where you're approaching 0 here, this is 1.998, and so that's just 0.002 away from 0, and this is also 0.002 away from 0 on the other side. So both of these are approaching 2. I can see that graphically, and I can see that here. So my limit is going to be 2. And if I averaged those, I would get a 2 if I averaged them just like I did on number 6. All right, so let's talk about approximating these graphically. So I'm approaching 0. I can't plug that in. Nothing can be factored and then divided out. There's nothing to rationalize. So I'm going to graph these. I could do some points in a table, but if you can graph them, that's also a nice way to do this. So I'm going to graph the sine x over x. And I'm also going to go ahead and put in the next equation, just so I'm killing two birds with one stone. So I've got sine of 2x over x. Um, if you ever want to plug two in at the same time, you can. And if you'd only want to see one of them, you can just turn that equal sign off right there, and only one of them will graph. So if you are looking at this, you are approaching 0. So as you are approaching 0, on the left side, you are approaching the y value of 2, and on the right side, you are approaching a y value of, oh, not 2, but 1. I can't count. You're approaching a y value of 1, so your limit would be 1. All right, so on the second graph, I'm going to go and turn this graph off and turn this graph on. All right, again, I'm still approaching 0, so from the left, it looks like I'm getting closer and closer to a y value of 2, and from the right, I'm getting closer and closer to a y value of 2, so my limit as x approaches 0 of that function would be 2. All right, so when we have some one-sided limits, remember when they have the little minus sign up here, that's going to be from the left, and this would be from the right. We're going to do these graphically. You could also choose some numbers on the left side of 0, or you could choose a number on the right side of 0 and see what you're approaching. I prefer just to graph them and look at them. All right, so I've got the absolute value of 2x over x. And we've kind of done some of these in the previous lesson. All right, so if I asked you to find the limit as x approaches 0, it would not exist because on this side, my x is approaching -2, or my y is getting closer to -2 as x approaches 0. And on this one, my limit would be +2. So the limit would not exist because they're approaching things that are different from both sides. On the left side, though, if I just say, what's it approaching on the left side, remember, if it's just a flat line, that's going to be your limit. And we talked about that in the last lesson. So if you look at that, as my x values get closer and closer to 0, my y value is approaching -2. And then from the right side, my y values are approaching +2. So from the left, my limit would be -2, but from the right-hand side, my limit would be +2. So we're going to do the same thing with number 11 using the x minus 6. On the bottom, x minus 6. So if I look at this one, I am approaching 6 from the left. So as I approach, x approaches 6 from the left, my y value is approaching -1. As I approach 6 from the right, my y value is approaching +1. So from the left, my limit is -1. And from the right, my limit is +1. So let's talk about how we can find a one-sided limit. So let's say I asked you, here's my function, it's a piecewise function, and I asked you to find the limit as x approaches 1 from the left. So you have to decide which one of these pieces is on the left. Well, if I'm approaching 1 and all of the x values are less than 1, that means that if this is 1 here, that would be all the values to the left side. So the less than will be your left side, and then the greater than 1 would be your right side. So if I am approaching 1 from the left, then I would use the left piece of the graph. So I'm just going to plug in a 1. So 4 minus 1 is equal to 3. All right, if I asked you to find the limit as x approaches 1 from the positive side or from the right side, then I would use the right piece of the graph, which is this equation. So I would plug 1 in for the x there. So that gives me 4 minus 1, which is 3. All right, so here's the deal. If I had asked you what is the limit as x approaches 1, for both of these pieces, it's 3, so the limit would be 3. All right, if they were approaching different things, then your limit would not exist. All right, so if I'm looking at number 13, this would be my left side because those are all the values that are less than or equal to 2. And these are all the values that are greater than 2, so that would be the right side of the graph. So if I'm approaching 2 from the left, I want to make sure that I'm at the left piece. All right, so I'm going to plug in 2. 2 minus 1 is 1. So the limit as x approaches 2 from the left would be 1. The limit as x approaches 2 from the right, I want to make sure I'm on the right piece, so that would be the 2x minus 3. All right, so I would plug 2 in. 2 times 2 is 4, minus 3 is 1. So the limit as x approaches 2 would be 1 because they're approaching the same number from both sides. All right, so let's kind of dive into some limits from calculus. When we start our first derivative lesson, we will also talk about kind of this process. So I'm going to give you a function and ask you to find a limit that looks really kind of scary. If you break it down, it's not that bad. So for the function that's given by f of x equals x squared minus 1, we're going to find the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. Okay? So what you're going to do is you're going to kind of take each piece, and we did some of this in Algebra 2, okay? You're going to take this piece and do it first. Then you will take this piece and tack it onto the back after the minus sign. So what you're going to do is you're going to take this equation that I gave you, and I'm going to put a big parenthesis where this x is, and I'm going to plug the 3 plus h into it. All right, that's the first piece, just taking 3 plus h and plugging it into your function. Then I have a minus sign, and anything that comes after a minus sign should have parentheses. And I'm going to plug in a 3 into my function. So that would give me 3 squared minus 1. So this piece right here is the 3 plus h, and this piece right here is the f of 3, and then I'm putting that all over h. All right, so I'm going to have to take 3 plus h and square it. So I'm just going to do it out to the side. So if I square 3 plus h, that's the same thing as taking 3 plus h times 3 plus h. So 3 times 3 is 9. 3 times h is 3h. H times 3 is 3h. And h times h is h squared. So that's going to give me 9 plus 6h plus h squared. Now, if you don't like that that's not in order, that's fine. You can rearrange it. I'm just going to leave it as is for now. So that's the 3 plus h squared. Then I have this minus 1. So inside here, I have 9 minus 1, which is 8. And then a minus in front. So this would be a negative 8. And this is all over h. So now I'm just simplifying. 9 minus 1 is 8. Minus 8 is 0. So all of these are going to cancel. And now I have 6 plus h squared over h. Oh, that's not a plus. 6h. I apologize. Now you notice all three of these terms have an h, so you can cancel an h from all of them, which is going to leave you with 6 plus h. Now that you've eliminated that 0 in the denominator where you couldn't plug in here. So you get 6 plus 0 is 6. So your limit is 6. All right, and the last problem here, I've given you the equation x squared minus 3x. You are to find the limit as x approaches 0 of f of x plus h minus f of x over h. All right, otherwise known as, I think, your difference quotient. All right, so we're going to first do f of x plus h. So everywhere I have an x, I'm going to plug in x plus h. So that would be x plus h squared minus 3 times x plus h. Then you have a minus sign, and then your function, just the f of x. You're not doing anything other than just writing down f of x, but you need parentheses because it's after a minus sign. So x squared minus 3x all over h. From here, you're just simplifying. Now, if you know how a squared term comes out, it always comes out as the 3 times the 3 being 9, the h times the h being h, and double of this multiplied together. So 3 times h is 3h, that makes 6h. So if you use that here, x squared, and then you're going to double x times h, so that gives you 2xh, and then h squared. It will cut down on your work dramatically. Then you're going to distribute this 3, so you get negative 3x, negative 3h, and then you need to distribute this negative, so negative x squared, positive 3x, all over h. Now you can do some canceling. So the x squared will cancel with the negative x squared. The negative 3x cancels with the 3x. And all you have left is 2xh plus h squared minus 3h all over h. Every single term can divide by h, so that would leave you with 2x plus, you'll have an h left here, minus 3. So now that you have your denominator with the h eliminated because you can't plug that 0 in, you can plug 0 in for the h. So that gives me 2x plus 0 minus 3, which will simplify to 2x minus 3. So your limit is 2x minus 3. So this is the first time that we have seen a limit have a variable left in it, okay? And that's going to lead us into our derivative lessons, and you can kind of see the cool things that work out with that.